Continuing on with our development for the turbo rocket engine testing, we've got our initial setup all more or less completed, and what we're showing here is our setup for just doing some testing on the gaseous hydrogen, gaseous oxygen torch igniter. So we've got it mounted up on its slide rail, and the plumbing is hooked up, and you can kind of see how it is kind of configured here. So we have each of our each of the main constituents of the testing facility shown here. So here you can see in the black frame is our test stand, and which we'll be mounting the turbo rocket on, and the associated plumbing, which you've seen in subsequent videos. This is just a little test card that holds some pieces of equipment on that we'll be wheeling out. And then over here is another bit of test equipment, another sort of support cart, which holds some of our control electronics and power supplies. In particular, you can see the torch igniter and how it's configured. Basically, we have hydrogen and oxygen coming in to the turbo rocket, to the torch igniter. It has a spark plug that's driven by this, basically it's a neon sign transformer. It's about 40,000 volts, but it provides enough spark and enough electrical energy to ignite the hydrogen and oxygen that come in on the torch igniter. Valving for the torch igniter is controlled by these valves on the test stand, hydrogen and oxygen, and then a purge valve for purging the igniter when it's on. These come into the igniter and they're ignited, and then they come out this little orifice at the end here. Now I've sized the orifices in the hydrogen and the oxygen side, along with that of the exit nozzle, such that we get a particular flow rate and pressure from a given supply pressure provided to those two gases. So that's how we can control and compute the flow rates and the respective mixture ratio and the chamber pressure within the igniter for the torch igniter. So it should be about what we are expecting, a pretty rich mixture ratio of about 2.24 and a chamber pressure of about 50 psi-G from supply pressures of around 150 and 100 respectively on the gas supplies. Now, as might have alluded to in the previous videos, the torch igniter works by sliding into position right in front of the turbo rocket engine, and then lighting it, and then we can retract it. And so it's on this retraction rig here that's driven by this pneumatic piston. So I was just going to show you that. So right now it's just driven by air and an air supply and a little three-way manifold. So it works very simply. When we pull this lever out, it activates the slide transition on the igniter. And when this thing is swung around about 180 degrees, it faces right in front of the turbo rocket engine test module, the Turbo Rocket Mark 6, which has been removed in this configuration because we're just doing some static testing on the torch igniter. So I'll activate that, and you can kind of see how it works. So when we're ready to push the torch igniter in front of the turbo rocket, we pull the little lever out, and it slides out such that the torch tip is in front of the nozzle of the turbo rocket. And then when it is ignited, we retract it, and it comes back in. It's all just air driven. So again, pull the lever out, and then push it in, and it retracts. In, out, in. So that's how that works. So now we'll wheel all this stuff out, these three cart elements, we'll wheel it out to the test stand and set it up, and you'll see it configured out there, and we'll have another video showing the setup once we get it set out.